Rail transport is a means of conveyance of passengers and goods by way of wheeled vehicles running on rails. It is also commonly referred to as train transport. In contrast to road transport, where vehicles run on a prepared flat surface, rail vehicles are also directionally guided by the tracks on which they run. Track usually consists of steel rails, installed on ties and ballast, on which the rolling stock, usually fitted with metal wheels, moves. Other variations are also possible, such as slab track where the rails are fastened to a concrete foundation resting on a prepared subsurface. Rolling stock in railway transport systems generally has lower frictional resistance when compared with highway vehicles, and the passenger and freight cars can be coupled into longer trains. The operation is carried out by a railway company, providing transport between train stations or freight customer facilities. Power is provided by locomotives which either draw electric power from a railway electrification system or produce their own power, usually by diesel engines. Most tracks are accompanied by a signaling system. Railways are a safe land transport system when compared to other forms of transport. Railway transport is capable of high levels of passenger and cargo utilization and energy efficiency, but is often less flexible and more capital-intensive than highway transport is, when lower traffic levels are considered. The oldest, man-hauled railways date back to the 6th century BC, with Periander, one of the 7 sages of Greece, credited with its invention. Rail transport blossomed after the British development of the steam locomotive as a viable source of the power in the 18th and 19th centuries. With steam engines, it was possible to construct mainline railways, which were a key component of the Industrial Revolution. Also, railways reduced the costs of shipping, and allowed for fuel loss goods, compared with shipping, which faced occasional sinking of ships. The change from canals to railways allowed for national markets, in which prices varied very little from city to city. The invention and development of the railway in Europe was one of the most important technological inventions of the late 19th century. For the United States, it is estimated that without rail, GDP would have been lower by 7% in 1890. In the 1880s, electrified trains were introduced, and also the first tramways and rapid transit systems came into being. Starting during the 1940s, the non-electrified railways in most countries had their steam locomotives replaced by diesel-electric locomotives, with the process being almost complete by 2000. During the 1960s, electrified high-speed railway systems were introduced in Japan and later in some other countries. Other forms of guided ground transport outside the traditional railway definitions, such as monorail or maglev, have been tried but have seen limited use. History. The history of the growth, decline and restoration to use of rail transport can be divided up into several discrete periods defined by the principal means of motive power used. Pre-steam, the earliest evidence of a railway was a 6-kilometer diolkos wagonway, which transported boats across the Corinth Isthmus in Greece during the 6th century BC. Trucks pushed by slaves ran in grooves in limestone, which provided the track element. The diolkos operated for over 600 years. Railways began reappearing in Europe after the Dark Ages. The earliest known record of a railway in Europe from this period is a stained glass window in the Minster of Freiburg im Breisgau in Germany, dating from around 1350. In 1515, Cardinal Matthias Lang wrote a description of the Reiszug, a funicular railway at the Hohensalzburg castle in Austria. The line originally used wooden rails and a hemp haulage rope, and was operated by human or animal power. The line still exists, albeit in updated form, and is one of the oldest railways still to operate. By 1550, narrow-gauge railways with wooden rails were common in mines in Europe. By the early 17th century, wooden wagonways were common in England and Wales for transporting coal from mines to canal wharfs for transshipment to boats. The world's oldest working railway, built in 1758, is the Middleton Railway in Leeds. In 1764, the first gravity railroad in the United States was built in Lewiston, New York. The first permanent tramway was the Lipa Railroad in 1810. The first iron plate railway, made with wrought iron plates on top of wooden rails, came into use in 1768. This allowed a variation of gauge to be used. At first only balloon loops could be used for turning, but later, movable points were taken into use that allowed for switching. From the 1790s, iron edge rails began to appear in Great Britain. In 1803, William Jessop opened the Surrey Iron Railway in South London, arguably the world's first horse-drawn public railway. The invention of the wrought iron rail by John Birkinshaw in 1820 allowed the short, brittle, and often uneven cast iron rails to be extended to 15 feet lengths. These were succeeded by steel in 1857. Age of steam. The development of the steam engine during the Industrial Revolution in Great Britain, initially for pumping water, spurred ideas for mobile steam locomotives that could haul heavy weights on tracks. James Watt's patented steam engines of 1769 were heavy low-pressure engines which were not suitable for use in locomotives. However, in 1804, using high-pressure steam, Richard Trevithick demonstrated the first locomotive-hauled train at Merthyr Tydfil, in South Wales. Accompanied with Andrew Vivian, it ran with mixed success, breaking some of the brittle cast iron plates. 2 years later, the first passenger horse-drawn railway was opened nearby between Swansea and Mumbles. Earliest British steam railways in 1811. John Blenkinsop designed the first successful and practical railway locomotive, a rack railway worked by a steam locomotive between Middleton Colliery and Leeds on the Middleton Railway. His first locomotive, called Salamanca, was built the following year. In 1825, George Stephenson built the locomotion for the Stockton and Darlington Railway, northeast England, which was the first public steam railway in the world. In 1829, he built the Rocket, which was entered in and won the Rainhill Trials. This success led to Stephenson establishing his company as the preeminent builder of steam locomotives for railways in Great Britain and Ireland, the United States, and much of Europe. In 1830, the first intercity route, the Liverpool and Manchester Railway, was opened. The gauge was that used for the early wagonways, which had been adopted for the Stockton and Darlington Railway, with a 1,435 mm width which became known as the International Standard Gauge, still used by about 60% of the world's railways. This spurred the spread of rail transport outside the British Isles. By the early 1850s, Great Britain had over 7,000 miles of railway, a stunning achievement given that only 20 years had elapsed since the opening of the Liverpool and Manchester Railway. Early railroads in the U.S. Railroads were built on a far larger scale than those in continental Europe, both in terms of the distances covered and also in the loading gauge adopted, which allowed for heavier locomotives and double-deck trains. The railroad era in the United States began in 1830 when Peter Cooper's locomotive Tom Thumb first steamed along 13 miles of Baltimore and Ohio Railroad track. In 1833, the nation's second railroad ran 136 miles from Charleston to Hamburg in South Carolina. Not until the 1850s, though, did railroads offer long-distance service at reasonable rates. A journey from Philadelphia to Charleston involved 8 different gauges, which meant that passengers and freight had to change trains 7 times. Only at places like Bowling Green, Kentucky, were the railroads connected to one another. The Baltimore and Ohio Railroad that opened in 1830 was the first to evolve from a single line to a network in the United States. By 1831, a steam railway connected Albany and Schenectady, New York, a distance of 16 miles, which was covered in 40 minutes. The years between 1850 and 1890 saw phenomenal growth in the U.S. railroad system, which at its peak constituted one-third of the world's total mileage. Although the American Civil War placed a temporary halt to major new developments, the conflict did demonstrate the enormous strategic importance of railways at times of war. After the war, major developments include the first elevated railway built in New York in 1867, as well as the symbolically important first transcontinental railroad, completed in 1869. Electrification and dieselization experiments with electrical railways were started by Robert Davidson in 1838. He completed a battery-powered carriage capable of 6.4 kilometers per hour. The Gross-Lichterfelder tramway was the first to use electricity fed to the trains en route when it opened in 1881. Overhead wires were taken into use in the Mödling and Hinterbrühl tram in Austria in October 1883. At first, this was taken into use on tramways that, until then, had been horse-drawn tramcars. The first conventional completely electrified railway mainline was the 106 km Valtellina line in Italy that was opened on 4 September 1902. During the 1890s, many large cities, such as London, Paris and New York City, used the new technology to build rapid transit for urban commuting. In smaller cities, tramways became common and were often the only mode of public transport until the introduction of buses in the 1920s. In North America, interurbans became a common mode to reach suburban areas. At first, all-electric railways used direct current, but, in 1904, the Stubaital line in Austria opened with alternating current. Steam locomotives require large pools of labor to clean, load, maintain and run. After World War II, dramatically increased labor costs in developed countries made steam an increasingly costly form of motive power. At the same time, the war had forced improvements in internal combustion engine technology that made diesel locomotives cheaper and more powerful. This caused many railway companies to initiate programs to convert all unelectrified sections from steam to diesel locomotion. Following the large-scale construction of motorways after the war, rail transport became less popular for commuting and air transport started taking large market shares from long-haul passenger trains. Most tramways were either replaced by rapid transit or buses, while high transshipment costs caused short-haul freight trains to become uncompetitive. The 1973 oil crisis led to a change of mindset, and most tram systems that had survived into the 1970s remain today. At the same time, containerization allowed freight trains to become more competitive and participate in intermodal freight transport. With the 1964 introduction of the Shinkansen high-speed rail in Japan, trains could again have a dominant position on intercity travel. During the 1970s, the introduction of automated rapid transit systems allowed cheaper operation. The 1990s saw an increased focus on accessibility and low-floor trains. Many tramways have been upgraded to light rail, and many cities that closed their old tramways have reopened new light railway systems. Innovations, many benchmarks in equipment and infrastructure led to the growing use of railways. Some innovative features taking place in the 19th and 20th centuries included wood cars replaced with all-steel cars, which provided better safety and maintenance, iron rails replaced with steel rails, which provided higher speed and capacity with lower weight and cost, stove-heated cars to steam heating cars, pipe from locomotive gas lighting to electric lighting, with use of battery alternator unit beneath the car, development of air conditioning with additional underbody equipment and ice compartment. Some innovative rolling stock included the lightweight, diesel-powered Streamliner, which was a modernistic, aerodynamically styled train with flowing contours. Then came the ultra-lightweight car with internal combustion engine in each train's power car. Others included the dome car, turbine-powered trains, bi-level rolling stock, and the high-tech, high-speed electric trains. Even more, in the first half of the 20th century, infrastructure elements adopted technological changes, including the continuously welded rail that was 1/4 mile long, concrete high-usage, double-tracking major lines, intermodal terminal and handling technology, advances in diesel-electric propulsion to include AC traction systems and propulsion braking systems, and just-in-time inventory control. Beyond technology, even management of systems saw improvements with the adoption of environmental impact concerns, heightened concern of employee and public safety, introduction of urban area rail networks and public agencies to manage them, and downsizing of industry employment with greater use of contractors and consultants.